The decimal expansion of pi is irrational, so it is non-terminating and non-recurring. Which of the following is a rational number? Root 36 is actually 6, so it is a rational number. If the HCF of two numbers is 1, then the two numbers are called relatively prime or co-prime. Root 3's expansion is non-terminating and non-recurring, so it is an irrational number. Every odd integer is actually of the form 2q plus 1, so the option is none of these. If sum of zeros of polynomial 3x square minus kx plus 6 is 3, the value of k is what? So sum of zeros of polynomial is given by minus b by a, so which is k by 3 here. So it is given in the question that k by 3 actually equals 3. So k is 9, which is the D option. Expressed as x square minus sum of zeros of polynomial of x plus the product of the zeros of polynomial. So the sum of the zeros of polynomial is given as minus 3. So minus of minus 3 becomes plus 3x. The product is given as 2. So the option is C. If root 5 by 3 and minus root 5 by 3 are two zeros of the polynomial f of x, then its other two zeros are what? So when root 5 by 3 and minus root 5 by 3 are two zeros, then x plus root 5 by 3 and x minus root 5 by 3 are the factors of f of x. So when x plus root 5 by 3 and x minus root 5 by 3 are factors, x square minus 5 by 3 also becomes a factor of f of x. So we are going to divide f of x by x square minus 5 by 3. So f of x is 3x power 4 plus 6x cube minus 2x square minus 10x minus 5, dividing it by x square minus 5 by 3. When I put 3x square, we have 3x power 4 plus 0x cube minus 5x square. Subtracting it, this gets cancelled. 6x cube plus 3x square minus 10x minus 5. So multiplying it by plus 6x, I get a 6x cube plus 0x square minus 10x. First and the third term gets cancelled. So I get a 3x square minus 5. So when I add it with plus 3, I get 3x square minus 5. When I subtract it, I get a 0. Now when I factorize this term, 3x square plus 6x plus 3 is equal to 0. Taking 3 as common, x square plus 2x plus 1 becomes 0. So x plus 1 the whole square becomes 0. So then x is equal to plus or minus 1. So the two zeros of the polynomial are x is equal to plus 1, comma x is equal to minus 1. Real number a is called the zero of the polynomial of f of x when f of a is equal to 0. Product and sum of zeros of quadratic polynomial. The sum of zeros of polynomial is often expressed as minus b by a, and the product of a sum of 0 of a quadratic polynomial is expressed as c by a. So it is option D. In a morning walk, three persons step off together and their steps measure 80 centimeter, 85 centimeter and 90 centimeter. What is the minimum distance each should walk so that each can cover the same distance in complete steps? Now, I am going to find a minimum distance which should be common to all the three members, and it also should be the least. So basically, the minimum distance is going to be the least common multiple of 80, 85 and 90. So finding it, I'll be getting 80 as 2, 40, 20, 10, 5, 5 and 1. So 80 can be expressed as 2 power 4 into 5. Now doing 85, I am getting 17, which is 85 gives me 70 into 5. When I put 90, the same manner, I get 3 square into 2 into 5. So the LCM of 80, 85 and 90 equals 12240 centimeter, which is the minimum distance.
Find the smallest number which leaves reminders 8 and 12 when divided by 28 and 32 respectively. So first we are going to subtract 28 and 8, which gives me 20, and 32 minus 12, which also gives me 20. Now I am going to take the LCM of 28 and 32. When I do the prime factorization for 28, I get 2 square into 7. Similarly, when I do for 32, I get 2 power 5. So the LCM is 2 power 5 into 7, which comes out to be 224. Now this is the LCM, but we have to find the smallest number which leaves the remainders 8 and 12. So the smallest number which leaves the remainder 8 and 12 is the LCM we have got, that is 224 minus 20, which gives 204. Thus the answer is 204. In a seminar, the number of participants in Hindi, English and Mathematics are 60, 84 and 108 respectively. Find the minimum number of rooms required if in each room the same number of participants are to be seated and all of them being in the same subject. Before finding the minimum number of rooms, I have to find the minimum number of participants who are to be seated in each room. So it should be minimum and it should be equal to all the members from various subjects, right? So we are going to take the HCF of 60, 84 and 108. Now this can also be done using the long division method or the Euclid's division lemma, but I am just doing the normal prime factorization method. So when I take prime factorization, this would be 2 square into 3 into 5. 84 would be 2 square into 3 into 7, and 108 would be 2 square into 3 cube. So our HCF should be 2 square into 3, which is 12. So what we have got is the number of participants who are to be seated in each room. Equally, in every room there are going to be 12 participants. Now then we have to find the total number of participants. Total number of participants would be 60 plus 84 plus 102, which would give 252. Now the number of rooms required is easy. Total number of participants by number of participants in each room. Number of rooms required is 252 by 12, which gives us 21. That is the answer. Renu purchases 2 bags of fertilizers weighing 75 kg and 69 kg. Find the maximum value of weight which can measure the weight of the fertilizers exact number of times. Now, the number of times should be exact and also the value of weight should be maximum. So I'm going to find the HCF of 75 and 69. So this would be 5 square into 3, and 69 would simply be 3 into 23. So HCF of 75 and 69 is 3. So maximum value of weight is 3 kg. Determine the greatest 3-digit number exactly divisible by 8, 10 and 12. So we are going to first find the LCM of 8, 10 and 12. LCM of 8, 10 and 12. When we do the prime factorization for it, 2 4s are 8, 5s are 10, 6 are 12. Again, when I divide it by 2, I get 2 cube into 5 into 3, which comes out to be 120. Now I am going to find the greatest 3-digit number in the 120th table. We know that generally the greatest 3-digit number is 999, but 999 is not divisible in the 120 table. So when I see the greatest 3-digit number, I get 120 into 8 are 960. And when I go to 120 into 9, it comes out to be 1080. So this is clearly a 4-digit number. So the greatest 3-digit number exactly divisible by 8, 10 and 12 divisible by 8, 10 and 12 is 960. Moving on to the next question. Find all the zeros of the polynomial x cube plus 3x square minus 5x minus 15. We are taking this as f of x. If two of its zeros are root 5 and minus root 5. When two of its zeros are given, we know that x plus root 5 and x minus root 5 are already a factor of f of x, are factors of f of x. So obviously x square minus 5 is also a factor of f of x. So we are going to divide f of x by x square minus 5. So x cube plus 3x square minus 5x minus 15. When we divide it with x square minus 5, we get x cube plus 0x square minus 5x. So when we change the sign, this gets cancelled. 3x square minus 15. So when I add a 3 over here, the whole term gets cancelled, 0. So I can now express my f of x, that is x cube plus 3x square minus 5x minus 15 as x square minus 5 and x plus 3. Now x square minus 5 is already a factor of f of x. So x plus 3 is also a factor of f of x. So we can write x plus 3 as 0. X is equal to minus 3 is 0 of the polynomial given. On dividing x cube minus 3x square plus x plus 2 by a polynomial g of x, the quotient and remainder were x minus 2 and minus 2x plus 4. So find g of x. So we are going to use the basic division algorithm here, which states that the dividend is equal to the quotient into the divisor plus remainder. Now we know that the quotient, now for a convenience I'm going to name the dividend as p of x, the quotient as f of x, and the divisor as g of x, and the remainder as r of x. Where we have to find g of x, so g of x is equal to p of x minus r of x by f of x. Putting the terms, I get x cube minus 3x square plus x plus 2, and remainder minus of minus 2x, which is plus 2x minus 4 by f of x is x minus 2, which gives me x cube minus 3x square plus 3x minus 2 by x minus 2. Now we are going to do the polynomial division for this. X minus 2, x cube minus 3x square plus 3x minus 2. So when we put x square here, the terms become x cube minus 2x square. First term gets cancelled when the sign gets changed, and the second term becomes minus 1x square plus 3x minus 2. When I add a minus x here, the first term gets cancelled on sign change, and minus 2 into minus x becomes plus 2x. On sign change, that gets cancelled, and this becomes 1x minus 2. Now if I add a 1 here, it becomes x minus 2 and the whole term gets cancelled. So our g of x comes out to be x square minus x plus 1. If the product of zeros of polynomial ax square minus 6x minus 6 is 4, find the value of a. Now let me name this polynomial as f of x. So let me consider two zeros of f of x. Let zeros of f of x be alpha and beta. Okay. Now my product of the zeros of polynomial is given, which is c by a 4. So the polynomial is given as ax square minus 6x minus 6. From this, c by a is minus 6 by a, which is given as 4 in the question. So a is minus 3 by 2. Next question. If alpha and beta are zeros of the quadratic polynomial x square minus of k plus 6x plus 2 into 2k minus 1, find the value of k if alpha plus beta is given as half alpha beta. Now we know that alpha and beta are the zeros of the polynomial. So we know that the sum of the zeros of polynomial is given to be minus b by a, and the product of the zeros of polynomial is c by a. And from the from the quadratic polynomial f of x, we are going to take b, which is minus of k plus 6. So minus of minus becomes plus. So b becomes k plus 6 and a is 1. So alpha plus beta is given as k plus 6, and our alpha beta is given as 2 into 2k minus 1. Now it is given in the question that alpha plus beta is equal to half alpha beta. We're going to substitute the values. K plus 6 is equal to half into 2 into 2k minus 1. The 2 gets cancelled. So k plus 6 becomes 2k minus 1, and k is given as 7. Next question. If alpha and beta are the zeros of the quadratic polynomial f of x is equal to 6 square plus x minus 2, find the value of 1 plus alpha plus 1 plus beta, 1 by alpha plus 1 by beta minus 2 alpha beta. Whenever such expressions are given, 1 by alpha plus 1 by beta minus 2 alpha beta, we have to first convert it in terms of alpha plus beta and alpha beta, as those are the terms for which we know the value. So in order to convert this as alpha plus beta, we are going to take LCM for the first two terms. So when I take LCM, I get alpha plus beta by alpha beta minus 2 alpha beta. Now this term is clearly, I know the values of alpha plus beta and the sum becomes easy. So first we have to find the values of alpha plus beta. Alpha plus beta, which is the sum of the zeros of polynomial, is always given by minus b by a, which is minus 1 by 6 in the polynomial, and alpha beta is given as c by a, which becomes minus 2 by 6 or 1 minus 1 by 3. So alpha plus beta is minus 1 by 6, alpha beta is minus 1 by 3, minus 2 into minus 1 by 3. So it becomes 1 by 2 when I cancel it, plus 2 by 3, which gives me 7 by 6 on taking the LCM. 20th question, second subdivision. If alpha and beta are the zeros of the quadratic polynomial of f of x, find the value of alpha square by beta square plus beta square by alpha square. First, we are going to express this term as something which we know. We only know alpha plus beta and alpha beta. So we are going to take the LCM for it, alpha power 4 plus beta power 4 by alpha square beta square, right? So I don't know the expression, I don't know the value of alpha power 4 and beta power 4. So I'm going to remember this identity, a square plus b square is equal to a plus b the whole square minus 2ab. Instead of alpha as a, I'm putting alpha square as a square and beta square as b square the whole square, which is equal to alpha square plus beta square the whole square minus 2 alpha square beta square. So I'm going to write it here, minus 2 alpha square beta square. Now I've got half of the sum. So again, I don't know alpha square plus beta square. So I'm going to use this identity again. I'm writing it as alpha plus beta the whole square minus 2 alpha beta. But we have to be very careful with the powers. There is a square here, so we have to put the square here also. Minus 2 alpha square beta square by alpha square beta square. Now we are going to substitute the values. Minus 1 by 6 the whole square, minus 2 into minus 1 by 3 the whole square, into minus 2 into minus 1 by 3 the whole square, by 1 by 9, which is 1 by 36 plus 2 by 3 the whole square, minus 2 by 9 by 1 by 9. So I'm going to take the LCM for 36 and 3. So it is 36 only. 1 plus 24 whole square minus 2 by 9 by 1 by 9. So the square of 25 is 625. So it's 625 by 1296, which is the square of 36, minus 2 by 9 by 1 by 9. LCM for 1296 and 9 is 1296 again. So it is 625 by 1296 minus 2 by 9 by which is equal to the LCM for 1296 and 9 is 1296, and 9 144s are 1296, so 625 minus 288 by 1 by 9, which gives me 337 by 1296 by 1 by 9. When I cancel 9 and 1296, I get 337 by 144, which is the answer.